All right, boys and girls. Today we're going to be talking about box plots. So our essential question is, how can you use a box plot and measures of spread to describe a data set? All right, so the first thing we're going to talk about is using a box plot. A box plot is a display that shows how the values in a data set are distributed or spread out. Okay, and the first thing that you need to know is, to make a box plot, you first have to find 5 values for the data set. All right, first thing you want to find is the least value. All right, that's what I would look for. The next thing you want to find is the greatest value. Those are probably the 2 easiest things to find in this whole thing. All right, then after that I would want to find the median. All right, because that's just simple. And then from there I would want to find the lower quartile, which is the median of the lower half of data, and the upper quartile, which is the median of the upper half of the data. All right, and that's all there is to using a box plot. Okay, so this may look a little daunting, but it is so not. Okay, so don't let all these words confuse you. I'll try to break it down as best I can. All right, so here's an example of how you find a box plot. It says the height of several students are shown, and you need to make a box plot for the data. So here's the height of the students right here. You have 60, 58, 54, blah, 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 all of the data. Okay, the first thing you want to do when you're making a box plot is order the data and find the needed values. And I told you there was 5 values that you had to find. All right, so once you get them in order, in this case we're starting with 54 and we're ending with 65, the first thing we know is that I have the lower data right there. Okay, that's the least value. All right, and then there is the greatest value. So those are the 2 values that you need. All right, that gives you the first 2. All right, so the next thing you have to do is to find the median. All right, so remember I taught you how to find the median by eliminating from the outside in. All right, so we eliminate 1, we eliminate 2, we eliminate 3, we eliminate 4, and we eliminate 5. And guess what? I have these 2 values here. Okay, in the last video, when we were eliminating to find the median, there was only 1 number in the middle. Well, here we have 2, and that's going to happen. So how you find the median, both 59 and 60 cannot be the median. You have to find the average of these 2 numbers in order to come up with a median. So that's what we've done. We take 59, we add it to 60, we divide by 2, and then the median becomes 59.5. Okay, that is the median of that data set. Okay, so that's the first 3 values. Next thing you have to find is the median of the lower quartile, and then the median of the upper quartile. So you use where the median is to help you divide. Okay, so from here to here, past the 59, but not past the 60, that's my lower quartile. And then from the 60 up to 65 is my upper quartile. So I need to find the median of those 2 quartiles. So once again, I eliminate from the outside in. All right, and here I have 2 numbers again, so 56 and 58. All right, if I add 56 to 58 and divide by 2, I come up with 57. That's my lower quartile. Then I do the same thing here, outside in. That's 1, then 2, and I have 2 numbers that are in the middle, 61 and 62. If I add those 2 up, divide by 2, I get an average of 61.5. So my upper quartile median is 61.5. All right, now you have to actually draw the plot. Okay, so first you plot these points. I plot the 54, I plot the 57, 59.5, 61.5, and 65. So that's what they've done here. They plotted 54, 57, 59.5, 61.5, and then way out here is 65. Okay, so that's the first thing you do, is you plot those 2 points. Then you draw at the median of the lower quartile, you draw a vertical box, or vertical line rather. At the median of the upper quartile, you draw a vertical line. And then at the median of the entire data set, you draw a vertical line. And then you just kind of box it in. And that's it, and that's your box plot. That's all there is to it. All right, so let's go ahead and try to make one on our own. It says the daily high temperatures for some days last month are shown. Make a box plot of the data. All right, so here we have all these data values, and I can tell you right now we got an even number of data, so that means we're going to have to find the median of the data. All right, so first thing we want to do is order it from least to greatest. All right, so I'm going to look through. I see 78 is my lowest, 78, 75. So 75 is my lowest value. All right, so I'm going to cross that out. Then I have, what, 75, 76, 77, 78 is my next one. So 78, and I have that. And I apologize, I'm writing with my mouse because I can't use my iPad right now. It's acting kind of wonky. So 78, 78, then I have 79. All right, that gets rid of that one. What's the next one? 80. All right, I have 80 is my next value. 83, 84, 85, 83, 84, and 85. And I'll probably fast forward this too. All right, 83, 84, 80, where was 85? There it is. So then I have 88, 89, 88, 89, all right, 88 and 89. Then I have 92 and 94. Remember, that is a 9. All right, 92 and 94, and that should be all my numbers. All right, 92, 94. All right, so now I have them in order from least to greatest. I got 1, 2, 3, 4. Well, first of all, 75 is my lowest one. So first thing I'm going to do is, let's see, 74, 75, 76. Okay, 74, 76, 78. So my increments here, my scale on this line, number line, is every line represents 2. Okay, so my 74, my 75, my lowest value is going to go right there between 74 and 76. My highest value is 94. That's going to go right there. So those are my two tails. Okay, so next thing I want to do is eliminate from the outside in. So I go 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And I got 83 and 84. These are my two values. I have to find the average of these to come up with my my median. So the average between 83 and 84 is 83.5. Okay, so 83.5. So 82, 84, 83. So 85, 83.5 is going to be about right there. All right. Not quite on this line, but between the middle point. It's like 3/4 of the way through. All right. So now I need to use that information to come up with the interquartile, or upper and lower quartiles. So I've drawn boxes around my lower quartile, and I've drawn a box around the upper quartile. So now I eliminate from the outside in. 1, 1, 2, 2, and I got two numbers here in the middle. Okay, so 78 and 79. My lower quartile is 78.5, and then my upper quartile 1, 1, 1, 1. I have these two numbers, 88 and 89, 88 and a half. Okay, so 78 and a half, 78 and a half is going to be about right there. 88 and a half, that would be 86, 88 and a half is going to be about right there. So in the instructions, I told you needed to draw a vertical line at the lower quartile, at the median, and then at the upper quartile. Color in your box, and then draw a line from your upper quartile to the highest value, and from the lowest quartile to the lowest value. And that's it, and that's all you have to do to construct your box. Alright, so the next thing we're going to have to find is the interquartile range. Alright, so a measure of spread is a single number that describes the spread of data of a data set. One measure of spread is the interquartile range. Another one is a box plot. We've already talked about that. Okay, so the interquartile range, or something we call the IQR, is the difference of the upper quartile and lower quartile. Okay, so here we have two box plots. The box plots compare the ages of dancers in two different dance troupes. Okay, so the upper quartile and the lower quartile are these numbers right here. So in this case we have 20 and that's the lower, and then the upper is 24 for that one. Okay, in this one, the lower quartile is 21.5, 21.5, and the upper is 26. Okay, so we want to compare, we want to have the difference. So if I subtract 20 from 24, I get an interquartile range of 4. If I subtract 21.5 from 26, I get a difference of 4.5. 4.5. All right, and that's it. That's interquartile range. There's not a whole lot to it. Okay, you can compare these numbers now. You can say that the dancers in group A, the ages are closer together in the middle part of the group compared to group B, where the ages are spread out a little bit further. And that's it. All right, the last thing that I want to talk about is finding the range. Okay, so the range is another measure that describes the spread of the data. All right, and it says the range is the difference between the greatest value and the least value of the data set. So you got to find the biggest number and the smallest number, subtract, and that tells you the range. And that's all there is to it. So here we go. We got the data set shows the ages of the players on 2 professional baseball teams. Find the range of each data set. Okay, so here we have this data for Team A, and we have this data for Team B. It says arrange the data sets in order from least to greatest. So that's what you do here. You arrange them from least to greatest. So in Team A, the least is A is 21. All right, I'll tell you what, let me scratch that and just circle it. So the lowest age is 21. The greatest age is 39. And then I just subtract 39 minus 21. And I get 18. So there's an 18-year spread between the youngest person on Team A and the oldest person on Team A. What about Team B? I have still 21, and then I have 31 as my oldest. So I have 31. Oops, I'm probably going to be coloring on my screen there. Let's scratch that out and say I have 31 minus 21. All right, 1 from 1 is 0. 2 from 3 is 10. So here I only have a 10-year spread versus Team A having an 18-year spread. So you can tell that Team B is a younger team, all right, just based on the spread of the ages. Okay, so the last thing is just an example. It says find the range of each set of data. Which city's data has a greater range? So we have the average monthly temperature in Fahrenheit, in degrees Fahrenheit. I have Miami, Florida, and Chicago, Illinois. So I'm not going to take the time to put all these in order, but I definitely want to try to find the smallest number. So 76 is smallest. Let's see. And that's my smallest number, 76. Oh, these are actually in order. Okay, I don't even, no, they're not. No, they're not, because I got these numbers over here. So my greatest number, I see, looks like 91. All right. So I have 76 and 91. So the difference between those two is 91 minus 76. All right, I got to borrow. That's 8. That makes that 11. So that's a 5. And then 7 from 8 is 1. So there's a 15-degree spread in Miami, Florida. Okay, for the average monthly temperature, high temperature. Let's look at Chicago. All right, 31 is my lowest. All right, and that is my lowest, 31. And I'm going to subtract that from the highest, which I have 80, 84, 84 degrees. 84 is my highest. All right, and then I subtract, I get a 3, and 3 from 8 is 5. So the average temperature, or the range of temperatures in Chicago is 53 degrees. So that means Chicago has a greater range of temperatures than Miami does. Miami only changes 15 degrees, where Chicago changes anywhere from 53 degrees. So that's it. That's how you use range.